This is a lecture about non-magnetic data storage for Comp 375 Computer Architecture Organization at North Carolina A&T State University.
So, Dr. Williams is going to tell you about a technology that no longer exists.
There are still a few data CDs and lots of movies on DVD and Blu-ray. Solid-state disks, or SSDs, do not have rotating magnetic disks. Instead, they just have a whole bunch of flash memory chips. The flash memory chips store the data, and they are much quieter, use far less power, and less vulnerable to vibration. And you don't need to seek or have a rotational delay to get to the data, so you can get to any data location as quick as you want to. They tend to run much faster than you'll find any rotating disks, so there's significant improvement in performance. The answer is B, less of a concern.
You can read from any chip at any time.
You don't have to worry about fragmentation, rotational delay, or seek times. Flash memory has to be erased before it can be overwritten. You flash a block of memory to erase it. According to the Intel Information, who makes a lot of the flash memory chips, a memory block is only good for about 100,000 flashes before it starts to wear out and errors may occur. To avoid this problem, the operating system generally creates a queue of available blocks. As it needs a new block, it takes the first one from the queue, and as somebody releases a block, it puts it on the end of the queue. That way, the blocks on the disk get generally used on an equal amount. And you only have to worry about the degradation after about all the blocks have been flashed about 100,000 times. Solid-state disk performance is considerably better than rotating disks. Some solid-state disks can make individual requests for 4K blocks that are about 41,000 blocks per second. Or if you want to read a continual stream of data, they can go up to 540 megabytes of data per second. Your standard high-performance hard drive can only read about 200 megabytes per second. Here's the specifications for a high-performance disk drive. You'll notice the seek time is short. Rotation is 15,000 RPM, which gives you a fast transfer time and a short rotational delay. In this particular disk, if you wanted to read a 4K block, it would take 4.64 milliseconds. Pause the video while you figure this out. Well, we know it takes 4.64 milliseconds, or 4.64 times 10 to the negative third seconds to do a read. We just want to know reads per second, which is the inverse of that. So we just invert the number, and we get about 215.5 reads per second, which is considerably faster, which is considerably slower than the 41,000 reads that can be done on a solid-state disk. CD-ROMs have been out for some time. They're in multiple formats. You can have CD-ROMs for data. You can have DVDs and Blu-rays. There was a technology called Laserdisc. Laserdiscs were large. They were about the size of the old-fashioned vinyl records, but they used the same technology as CDs. At that time, they couldn't put more data on the disk, so in order to store data for a movie, they made them bigger. CD-ROM has several layers. Basically, it's a piece of aluminum between a couple layers of plastic to protect it. The aluminum has spots on it, or pits, that affect how much light is reflected. They shine an infrared laser on it and it reflects. If there's a pit, it doesn't reflect very well. If there isn't a pit, it reflects. So the system can detect how much light is being reflected and know whether there's a 0 or a 1 there, whether there's a pit or not. On a CD-ROM, the pits are approximately 100 nanometers deep and about 500 nanometers wide. And that varies in length. The information on a CD is written in one long spiral instead of having concentric circles as you do on data. That's because CDs were originally manufactured for music, and you read lots of music instead of seeking to individual portions of the disk. So they were built for a long read, and so all the information is one long spiral. I calculated it's about 5¼ kilometers on that spiral. Here's a diagram showing you what it looks like on a CD. B is the shiny layer of aluminum that reflects the light. It's surrounded by plastic layers that protect the aluminum, and then on one side they have the label, the artwork. CD-ROMs have about 2K data bytes per block. Now they're included in the data byte. In addition to the data bytes, there's a 16-byte header that tells you which block this is, and there's 288 bytes of error correcting codes. That's so if you're driving across railroad tracks while you're listening to music and a byte or a bit is read incorrectly, then it doesn't have to go back and read it again. The error correcting code should be able to correct the error. Now, music CDs are recorded with 44,100 samples per second. That's because you need to have at least 2 samples of the wave in order to record it accurately. So if you have 44,100 samples per second, you can record signals of up to 22,050 cycles per second, or 22,500 kilohertz per second. They use 16-bit samples. That is, each value that's read is a number between 0 and 65K, or 2-byte samples.
Oh, Dr. Williams' ears can't hear up to 20K.
It's important to record the higher frequencies and harmonics so the music sounds correct. When you look at the CD speeds, they often refer to it as a 16x or 40x CD. A 1x CD is the speed of a music CD player. Music is played at 1x, which is 75 blocks per second. So if you have a CD-ROM that's 10x, then it would be 750 blocks per second. CD-ROM players have a very large head, so their seek time is slow, generally around 90 milliseconds. And considering that for most hard drives have a seek time that's less than 9 milliseconds, it's about 10 times longer. Therefore, they're really good at reading large files as the music spirals around, but you don't want to do a lot of seeks because the seeks are slow. This tells you that you can store large files efficiently on a CD, but don't put a lot of small files on a CD. If it has to seek out and find the small files, it's going to be slow. Pause until you find the answer. Okay, if we have 20K file and there are 2K per block, then it's only at 10 blocks of the CD for the file. And then if you want to know the transfer time, it's 10 blocks read at 24 times 75, which is 1800 blocks per second, and that gives you 5.6 milliseconds for the transfer. Now you have to add the 90 millisecond seek time, the 3 millisecond average rotational delay, and you get a total time of 98.6 milliseconds. There are several different ways to record the information on a CD. If you buy a CD from a store or through the mail, the manufactured CDs have a sheet of aluminum where they have pressed very tiny bumps to make indentations that will not reflect as well as the unbumped part of the aluminum. You also have CD recordables, ones that you can write once. They have an organic dye on the aluminum, and then a higher power laser light burns those little spots, and so they don't reflect as well. So you can record on a CDR, and it will burn little spots on the organic dye on the aluminum, so it doesn't reflect. You can only do that once. You can't erase the spots. There are CD rewritables where you can erase the spots. Some clever engineer figured out you can put a particular material on it, and at one temperature you can crystallize it, and it will melt and reform into a transparent value. Or at certain temperatures you can kind of burn it and make it opaque, so you can write on it and then later erase it. CD rewritables don't have a very high read-write cycle. You can usually do them 10-20 times before they start to wear out. The different types of optical disks have different lights that they use and different capacities. Your typical CD-ROM can hold up to 750 megabytes, and it uses an infrared light. A DVD used for holding movies can hold 4.7 gigabytes, and it uses a red light to read the information. As you might expect, Blu-rays use blue lights or a blue-violet sort of light, and they'll hold much more information, up to 25 gigabytes. If you remember your physics, the wavelength of light determines the size of the object that can be seen with that wavelength. CD-ROMs have pits that are about 800 nanometers, and they use a 780 nanometer wavelength, so they can just barely perceive those spots and nothing smaller. DVDs use a smaller 400 nanometer spot, and they can use a 650 nanometer wavelength. Blu-rays can hold even more information because they use a much smaller 405 nanometer wavelength, so they can resolve smaller objects than you could with, say, the CD-ROM light. It took the engineers quite a bit of time before they could develop an inexpensive LED that worked at the 405 nanometer or the blue light size. Thumb drives are typically a flash memory chip and some other information or controlling devices that allows it to connect to a USB. Here we have a flash drive that's been opened up. You can see the various parts. The big part is the flash memory, and then there's the controller chip, usually a clock chip to keep it all running on speed. Some of them have a read-only switch, which is a really nice feature if you need it. That way you can turn it to read-only, plug it into a system, and you can be ensured that system won't write anything on your thumb drive and won't catch any viruses or any malware. Homework will be coming up on disk systems. Put on Blackboard, and you'll need to provide your solutions by midnight on Wednesday, April 8th.
Homework every week to keep you from getting bored.
You learn by doing.